All right, folks, so again, I think we are looking at that canopy architecture that Eric was talking about, okay? But we are exposing them to different management, right? You will see here those erect and what we call droopy types, right? I have an image here, maybe I think it's easier to see over here. You can see this V, that angle at the bottom, right? You can see the difference in that angle, right? One is very narrow angle, the other is wide, right? So that's what's helping filling that canopy or going more erect, right? So what we are again looking is, can we manage them differently? You can see the strips going this way are the two different planting dates. The taller lookings are the early planting, end of September or so, okay? The other one right over here to my right is the early planting. The one I'm standing, this is the later planting, end of October or so, right? So you can see the difference here. And my hypothesis is that if we are able to plant early, we're gonna close canopy, right? That's not our worry. Our worry is not getting the canopy at the bottom shaded out. So some of these erect types might help us with that. That will keep getting the light down to the lower parts of the canopy and keep them going, right? They will keep photosynthesizing. But if we are under these delayed planting conditions, and you can see over here, the canopy wasn't even closed, right? That if we are delayed, we can benefit from some of these droopy ones, the ones that have these wide leaf angles or tailor angles even, right? And that can help us intercept more light during that growing season, right? So that's one idea. The other one is within each strip, I bet you can't even tell which one is a higher and which one is a lower seeding rate. One plot is 0.8 millions, other is 1.6 millions per acre. So double, right? And it's going to be pretty hard for you to really separate them out at this point. And that shows the ability of what a wheat plant can do, right? As long as we give them that space, having that early planting for them to tiller, to get those 4 to 5 tillers in that fall time, right? So that's another idea we are chasing, that maybe with these erect types, we can fit more plants in the unit area, just like what we are able to do with corn, right? So that's sort of the goal there. With these droopy ones, they're already intercepting a lot of light. So maybe we don't need to push them to a much higher seeding rate, right? And actually, Eric did look at some of the data from their intensive management plots. Our goal is we are applying more products out there, right? We are already developing the dense canopy. So we are seeing that if you are looking into intensive management, some of these erect types might actually do pretty good. So we actually have some data showing that, because you are not shading that bottom canopy, right? You have this thicker canopy overall, and you're still able to get light down to the middle and bottom of that canopy if you use an erect variety in your intensive management system. All right? We have some signs back over here, so feel free to have a look. They're pointing away from us, so you probably have to go around and look. And each sign points out to the same variety. One side is lower seeding rate and the other side is higher seeding rate. And at this point, it's pretty hard to tell them apart again. That shows that tillering potential, right? Any questions, comments?
We have so many wild relatives.
All right.
We have microbes.
So the signs are in this very last step. If you want to look at which variety is what, you can come over here and look at these signs. We start with, I think the first 7 or 8 plots are droopy types, right, Paulo? And then the 7 or 8 towards the end are those erect types. And we have the planting dates side by side. Right here is where our separation is. And if you see a lot of gaps here, we actually come in season and we take out these plants so we can estimate how much biomass they're producing, right? And we also measure, we come in here and we look at how much light they were intercepting. So that way we can estimate how much biomass they're producing per unit of light interception, okay? And that tells us that use efficiency, not only the interception of light, okay? So again, a lot of ideas here, but we need more research data to really give you which way we think it's gonna go, right? My hope is if you look at down the road over there, those erect types, that's what Eric was talking about. If we go in narrow row spacing, maybe go with the precision system, drop our seeding rate, then I think it all will work out, and we can even manage them more intensively and get to that higher yield potential. I think that's like a 5-year goal that I'm thinking here.
Did you talk about the seeding rate differences?
Yeah. So right here, I mean, again, look at these two plots, right? One is twice the seed of the other. Can anyone tell from
which
me?
one has the higher seeding rate?
So between these
between
two,
these two?
standing right here, which one is higher, which one is lower between these two,
That one over there is higher.
right? So yeah, you can pick it apart, but this is half of what's over there.
So
This is half.
Yeah, this is 0.8 million seeds, that's 1.6 million. So it doesn't look like half, right? You have an eye for it, so you could tell this is lower, but I don't think you would say it's half of that one. Is that fair?
No, yeah, that's fair. Yeah.
Right?
You can just say that's thicker over there than
Yeah. So yeah, we'll have yield data from these, and again, I think the idea is that can we again, does this response vary between these erect and these droopy types? Is what we are getting to, right?
How many more tillers is in there? How many more tillers?
We'll find out. We have data. Have you looked at numbers, Paulo? Probably not yet. We are counting. How many tillers? Tillers per plant.
Per plant,
Versus how
we count in half,
Yeah, half a meter.
half meter.
Yep, right.
We count around 30, 40 in half meter in the middle of the plot.
In here, how many over there? You remember?
Compared with this one, is very close. This one can be 30 and the one can be 45, 50.
40 or so. Okay.
Yeah.
Is 30
half.
enough to maximize yield? That's what we'll find
Yeah,
out, right?
Right.
That's what we are chasing,
Yeah.
right?
heads are smaller over there.
That's a good point. We'll collect data on it. We'll harvest some plants and we'll do like number of kernels per head, kind of an estimate. Looking it over, I don't know if I can really tell them apart. But that would be the hypothesis, that even though you have more tillers here, you probably have less number of kernels per head. So at the end of the day, again, the number we are trying to maximize is number of kernels per unit area, right? And you can do it in multiple ways. That's what we are trying to figure out here, right? So you will see over here, we have 4 and 4. So what Eric is showing you over here, he has more than 100 lines. We went there, we did some light interception measurements, we took some canopy readings, and we picked 4 varieties that we think are more of these droopy types, and 4 that were more erect types. And that's what we are testing over here, right? Another difference you will see over here in our research plots, I forgot to mention, there is this gap between the plots, right? So our assumption is that one variety might be able to utilize this gap better than the other one. So that can potentially create a bias in the data that we present, right? So we are looking into that too, that is there really a difference when we make our breeding selections, right? When Eric is doing that, is he favoring these droopy types more because they are able to get into this extra area that you all don't have in your field, right? And do we have like sort of a potential bias against some of these erect types because they are not able to utilize this space as much, right? You have that chart thing, I think so if you look again, I don't know if Eric has any number. Most of the lines, when I look at them, they are what I call droopy types, not the erect types. Maybe it's because of there is a genetic difference. Maybe it's partly because of this potential bias we're introducing, right? Because we have this extra space that we need to drive through, right? This is from last year. This is a chart I was trying to look. If you look at this chart, so this by like all the varieties that have a scale rating of 1, those are the droopy types that like expand. The 4 and 5s are the erect types. And if you look at the number of dots on this here, most of them are towards the bottom, right? Showing that a lot of lines that are in a breeding program and even in commercial testing, they are these droopy types. So we're trying to see, okay, is there something that we can really do with these erect types and really get to the bottom of that? And is narrow something to keep an eye on in there as well, right? Jeff, I think you were doing your narrow rows using an erect type, right?
Correct.
But what are you finding out? You think it's helping?
You know, I
in
don't
that system?
know. I'm not sure we've found a correlation to it yet,
Okay.
but it's definitely very interesting when we get to the narrow rows. You know, we were just commenting on the way over here, the 7.5-inch rows, you look at them, and with the erect type, there's just a lot
Yep,
of
there's a lot of
wasted space in here. I don't know if that's the right word I want to use, but with the narrow rows, you're filling that in. Lower populations, I don't know if we're in the right direction. Our yields have been pretty decent, so.
But that's the hypothesis again I have, is if we go to narrow rows, I think we can go with erect types, and we can then maybe bump or keep the relatively higher seeding rate, you know, just like what we do in corn, right? That we are able to, with these erect types, we are able to put more plants in a unit area. So that's the hope that we will, again, we need more data to really get to the bottom of it.
I know you can't do anything about it. How come 60 pounds of weight won't buy 2 loaves of bread?
Nothing I can do about it, right? So. And folks, be careful walking here. We're gonna be harvesting these as well, right? You will see a couple of plots that have all the holes in them. You can walk in there and pull out heads or whatever. But the other plots, try to be little careful. We appreciate that. Any other comments? I think that's all I had to say here. We can move over. I think Eric had a few more plots over there to talk about. Everyone good?
So far,
So far so good?
So for 7.5-inch rows, we should be using the droopy type, right?
Yeah, I think for the most part. That's what even this chart shows. Most of our genetics is there anyways, right? But I think there is an avenue again. That's a game. What we're talking is 2, 3, 5 years out.
How many years have you done the bulk spread?
The 2, 3 years, something. Yeah. So yeah, we still have ways to go there. In terms of
Everything. Cost, yield, profit.
Yeah, I mean, if you think profit, I think at the end of the day, right, your goal is not simply maximizing yield. You're trying to cut down your input costs, right? So I think that it comes back. We are running some economic analysis right now to go from yield to profitability, right? But again, it does come down to farm, right? Like what's your system, what's your operation looks like, what do you have, right? So it gets a little bit complicated, and I would hate to like journalize it.
A friend of mine's got a bunch of it this year. Done half of the spreader and half of the drill.
Oh, okay. Okay. So to me, I think the spread is mainly like if you're able to plant early, you know, that to me is the I don't think you're gonna gain by going to spreader compared to a drill. You will gain if you go to narrow row spacing, a more precision planting system. But you're not going to lose is I think sort of my hypothesis. If you can make it work cheaply, that's where the profitability comes into play, right? If you can spread it relatively cheaply compared to using a drill in a timely fashion, that's where I think the benefit comes from. I think again, so that trial we have done it for 2 years. This is the 3rd year that we have that trial in ground. I think Jeff was the first year, right, where we had 140 bushels by broadcasting seed.
And yeah, based on that information, we should take our expensive planter and put it up for sale because it didn't make a bit of difference.
Yeah.
But that was an early planted plot.
Yep, early planting.
So this year we have the same plot again, all the different tillage types or planting types, but we planted later in the season.
Oh yeah, this is yep.
Ours is later in the season because we think, yeah, maybe later in the season it's more important for that, you know, proper seeding depth distribution across there. So we'll have really good information here in another month.
And actually, that's a pretty good comment. I think where we have seen a higher benefit going with the precision system, going back to a small plot work, the year when we were delayed, we were seeing like even up to 20% yield benefit. But the second year we were able to plant very early, and we only had a 5% benefit by going to a precision system. So I think you're onto something there. That it probably plays a role when you are able to get it done.
Tilling it should save a chemical cost in the fall.
Yeah.
Better canopy, yeah. There's a lot of times we won't even put herbicide on our fields for weeds because we have such a good canopy out there that the weeds don't have a chance to get through the canopy. So that's another advantage, yes. What's the threshold for cereal leaf beetle?
I don't know.
I can't remember either.
I don't
There's
know.
going to be quite a few in here.
Yeah, they were starting to show up. We have sprayed in the years past. I don't think they have ever been at the threshold level around here. We sometimes still hit them, you know, because these are research plots and we don't want any, but yeah, that's a Chris DeFonso question. Maybe I
Yeah, right.
should ask. Didn't see her today. Anything else, folks? Otherwise, I think Eric is waiting out there for us. We can keep going. You don't have the alleyways from here on, but you can see where the tractor tires are, so you can just walk between those two, right? And try to avoid the plot area.